Hey fellow nerds, my name's Dom. Today we're going to be talking about design. Most FTC teams do not create their CAD designs before fabricating the robot. Instead, they make their robots on the fly. This can make for functionally and aesthetically poor robots. Designing your robot before building it allows for a smoother fabrication process. Today, the awesome nerds are going to explain to you why you should design your robots before building them. So you may be wondering, why go through the trouble of designing before fabricating? Well, allow me to show you a few parts from previous years.
I designed this part 3 years ago for our drivetrain. It supported the gears connecting our motor to our wheel. This part was designed in CAD. However, the design was not followed to proper specifications, and it was manufactured without review. This led to us costing time, resources, and quality. A lot of the final CAD product was put together after the part was created. This is very poor practice and is what many teams do for their design. In addition, fabricating parts without a plan leads to mistakes. For instance, these holes here look like the machinist forgot their glasses. They're rough and coarse, two things I absolutely hate. This is also a safety hazard and could lead to a team member getting injured because of the sharp and rugged edge.
Engineering without a plan leads to mistakes. Without a well thought out, refined design, you're more likely to make bad choices while fabricating. These mistakes can translate into what we call a Swiss cheese robot, or robot with holes everywhere. In the world of FTC robotics, nobody likes Swiss cheese. Properly designing your robot will give your team a proper guide, so that when you fabricate, you can not only get it right the first time, but your robot will look nice. Swiss cheese parts and other parts that are overused eventually become unusable. When these scraps no longer work, your team needs to buy more. In short, building before designing will waste resources and your time, both of which are really important to a team's success. As you can see, fabricating a robot without a plan can get really messy, and the process is inefficient. Now, we'll show you what a part can look like when you design first.
This part was created the year after the other part. It serves the same function as the other piece, supporting our gear train to our wheels, but this piece is much better. After getting some expert advice, we learned the best practices to follow when machining. This is very evident in the parts form. It is smooth, rounded, and very visually pleasing. Not only that, but the holes look nice, and the part is safe. This is one of my favorite parts I have designed, and the final unit shows the effort put into it. Our assembly was as simple as screwing in a few screws and sliding in a few shafts. Not many teams can say the same. This would not have been possible without the weeks of planning, reviewing, and redesigning that went into the part before fabrication.
When you design like this first, you're going to have a better product and an easier time building, since you actually know what it is that you're going to build. Planning saves time during fabrication, as well as materials and money. When you make a design for your robot, you also have yourself a set of blueprints to work with during fabrication. If it seems as though you might have messed up during fabrication, look over your design and compare it to what you're building, so that you can figure out what you made a mistake on. At the end of the day, it's more professional to design first. In the engineering industry, teams plan out their designs first. It's more efficient and cost-effective to go in with a plan. That's why planning gets its own step in the design cycle.
There are many different processes for designing a part. Most of these boil down into 4 steps. These steps are identify, design, refine, and manufacture. The first step, identify. To properly know what you need to design, you will need to get an idea in your head what it will look like. Making some quick sketches or kinematic analysis saves you weeks down the road when you are stuck because you don't know what you're designing. Don't focus on the specific dimensions, just try and get a good plan. In this step, you also try and find the cost materials, the commercial off-the-shelf products you want to use. This includes things like gears, shafts, motors, bearings, pulleys, and whatever else your team can't make. By identifying these now, you can lock in your next step easier. Step 2. Design. In this step, you take your idea and your list of parts, and you create a 3D model around it. This is when you break down the specifics of the part. By the end of this step, you should have a 3D model that could work for your part. This is also where you assemble all of your parts into an assembly, allowing you to see the interplay between your various parts. This is significant for your next step, refinement. Refining a part is about trying to get the best version of a part possible. This includes cutting out unused chunks of material to save weight for your robot, seeing if parts will structurally last, and many more. In this step, you also run stress tests of your part. This process is very simple in Fusion 360, but that will be covered in a later video. You can spend weeks on refining a part. That is what professional engineers do all day. However, it is important to know when you can call a part good enough. It doesn't have to be perfect, just functional and reliable. If you think you're ready, you can move on to the final step of the process. Step 4. Manufacturing. In this step, you will create your part using real material, whether you're using CNC, 3D printing, or a good old-fashioned drill press. You will want to ensure accuracy in your part. This can be your shortest step in the design process depending on your part and your methodology for manufacturing. Hopefully these steps will save you money and time, as well as your sanity when creating parts for your robot.
Thank you for watching. We hope you've learned about the benefits of designing before fabricating. The next video in the series will teach you how to use Fusion 360 to design a robot, so stay tuned for more.